Okay. Um, so this was another one of those big things that I was talking about, and it certainly took a lot of my time. Um, right. So recently there was this short course which was called Mathematics for Machine Learning or something like that. And we basically read through the book called Mathematics for Machine Learning, and I read till the ninth chapter. So there are still some chapters that are left, and I'll complete those soon. And by soon I mean in vacations, of course. I'll also like probably do NLP or something like that in vacations if time permits. Um, right. So what's this about? Well, the first year there was a statistics course which really taught me a lot of concepts about probability and you know categorization of data, like building classifiers. I built my first classifier on my own. It was a naive Bayes classifier, Gaussian naive Bayes. Then I did a lot of weird stuff like tried to implement SVC on my own, which failed horribly, and there was a lot that went on. It was the usual linear regression and all that. But I never really like understood why I'm doing what I'm doing. As in, I was seeing the results and I was intuitively getting that I'm doing something that corresponds to, you know, minimizing some kind of loss function which represents how close two quantities are when they're vectors or something like that. Yeah, I was intuitively getting it. But to get it like in detail, that's a whole other thing. Um, and moreover, that whole course, well, it was not very presentable to the masses. That's how I'll say it. I still have those notes that my professor made during the lectures, right? And those are still very useful for me, but not very useful for the masses. Um, so, what I aim to do is create a kind of compilation of everything that has happened in my 1 point something years at ITGN, um, that enabled me to kind of figure out what this machine learning stuff really is, right? um, and the most recent thing was the course Mathematics for Machine Learning, right? So before you go in you should be somewhat familiar um, with like linear algebra and some other stuff, probability stuff like that, which is covered in the book, no doubt about that. But it doesn't hurt to get a bit more knowledge about that. Also, there was a bit of group theory that was used at the first few chapters, like vector spaces and all. That's unnecessary. Honestly, I kind of feel that the book goes into topics which it shouldn't go into. But yeah, if you want to get a good hold of group theory, I have also linked that whole thing, which I did write a lot of stuff about recently. um, also like 3D coordinate geometry, there's some multivariable calculus that you need, so like vector calculus, you need like you need to know some kind of matrix decompositions like SVD, um, or the eigenvalue decomposition, so things like that. So this quadratic forms, by the way, that's just eigenvalue decomposition and some more stuff based on that, right? Yeah. Okay, and now let's get to the main thing. So these are all the 9 chapters that I went through. First, you have linear algebra. Um, right. So, linear algebra has all of these topics, which I am not going to open and show you what. Okay, I'll just show you like one glimpse of the whole thing. So, this is how I've written stuff down. So, yeah. And there are also some headings which were not in the book, and I made them myself because I felt that those were necessary. Like, an average reader wouldn't understand what's going on, and neither did I. But yeah, I made those headings anyway. So it's pretty well planned out how this text is going to go. So yeah, just go over these notes and you'll be good to go. Like, all you'll have to do is just read the other 3 chapters, which I still have to do. So maybe you can wait till I do that, and then you can read that, or you could just start on your own. But anyway, these 9 chapters are certainly there. The favorite one, or the one which I spent the most time on, was um, was continuous optimization. So, and by the way, we have a course called numerical methods going on right now, which deals with stuff that is like related to this. And one numerical method that we discuss a lot is the gradient descent, and that has a bunch of variations which a certain article covers very well, which I've linked over there. So this is that article. You can go through that. Don't go through my notes for this thing. But yeah, my notes do give a good description of what exactly we are doing. And then there are some applications which I have done, so I have linked those as well. The project reports of those applications, sometimes just the code if it's a personal project or something like that, right? But yeah, you have gradient descent, that's one numerical method, and then you have the Newton-Raphson method, and then you go into constraint optimization, where once again you can apply gradient descent but under constraints. So you do some other stuff like taking the projection on a null space or something like that. um, just read through it, you'll understand what's going on. And using that algorithm, the gradient descent under constraints, you can actually derive the Lagrange multiplier thing, that the Lagrangian, well, that guy's derivative with respect to the complete variable vector, that should be zero. Sorry, that should have, what was the thing? Yeah, so the derivative of the Lagrangian with respect to the vector that contains all the different the new parameters, that should be zero. Yeah, I mean, that was the thing, I guess, right? And that kind of represents some kind of linear dependence and something like that. So yeah, it's a lot of stuff to take in. I'll just show you a glimpse. So this is the usual Lagrange multiplier for equations, right? So you have something like delta nabla f of x naught, nabla g1 of x naught, g2 of x naught, nabla. These are linearly dependent, as in some linear combination of that is equal to 0, something like that. Where you could also think of it as being like the nabla functions themselves are 0, and then that's happening under some other new constraint, and there's stuff going on. Okay, but anyway, I'm not going to go into detail over here, and I'm sure that you got nothing from me just talking to myself. But just read this. Trust me, just read this, and you'll really understand what I went through to write these 5 subheadings. But yeah. Oh, I also like kind of uh, like the book also talks about linear programming, which apparently is pretty popular, because this I saw in some 12th grade textbook on calculus, and at that point I was not quite understanding what we are doing. I intuitively understood it, but now I really understand it, what we are doing. So yeah, that's linear programming for you. And then after constraint optimization, there's convex functions, which till now I've not exactly find a use for, because we haven't talked about a convex function that we want to minimize or something like that. But yeah, I hope there's some use for it later on. I still have 3 chapters to read, right? Yep. Okay, so that was continuous optimization. Now, one of the second best things that I did was write matrix decomposition in a lot of depth. So yeah, I kind of actually feel that this was unnecessary. I probably shouldn't have written this in this much of depth, but it's something to behold. Particularly this, the singular value decomposition. I made a video about it in the past, and I basically rewrote the same thing but in text. And so this was what that video was centered around, this animation of um, different, what do we even call this thing, different terms of a sum being added up. Well, this is the ith term, it's a matrix which we can picturize. Okay, that is literally picturizing, so which we can visualize as a picture, right? with the matrix values being pixels. And so these matrices, we add them up, and then that creates an actual image that we are like concerned about. So in this particular case is this image. And so yeah, that's what SVD is all about. And then the ones with the bigger singular values, that's the ones you keep. The ones with the smaller ones, you just discard all of them and stuff like that. So it's used in image comparison. um, yeah, but I think like the JPEG thing, that uses SVD, I think so. Well, anyway, then I also go on defining this thing called spectral norm and all that stuff about it, which I have not found that much use for yet. But yeah, all in all, it was a good read. Okay, and just to give you a good glimpse of what is in this mind map, pause this video and like just take a look at it, and you'll kind of understand what's going on, right? um, right, so that was matrix decomposition. Okay, I yeah, so that was matrix decomposition. Then I also did linear regression again and again, um, because recently I also used this in a project. But yeah, I did that in quite a bit of depth, going from the probabilistic model all the way to how do you actually minimize the loss function. You can do it analytically, you can do it with gradient descent or something like that. And then also different variations of linear regression. And the book really goes into all of that in depth. And it's sad, but I have to lead. I have to like leave some parts out because I suppose at that point the reader would be able to actually derive all of it on his own. So I'm leaving some stuff out. But yeah, there's that. And then the linear regression in action. So I have put two examples which we just do on the spot. And then there's this project report that I made for a recent course, and it uses linear regression, so I just linked it there. Alright, cool. So this was like the application of all that we learned. Although it's not a very big application, linear regression isn't much. There's also some other stuff like logistic regression and who knows what, which looks better. I mean, it looks more interesting. um, but yeah, I still have 3 chapters to read, so hopefully I'll cover that as well someday. And then I'm also linking all the different kinds of implementations that I've done regarding similar topics which are somehow related to this stuff. um, so these three are like really good project reports for some things I've done. And then you have a whole GitHub repository full of code and PDFs and books and um, and this whole thing, the whole this whole page as a website, right? So the repo also contains that. So really, if you want to get started, just click on the repo and see what's going on with me currently. And yeah, so this is really for people who have no clue as to where to go. If you are someone who has kind of a clue, just read MML, just read Mathematics for Machine Learning, that book. It's pretty nice, and I'm sure you'll learn a lot. But yeah, let's hope it helps someone. So that's it, and I'll see you guys in the next video.